So when we look at this extends common state, what we're looking at here is actually a reference to a class in 4DFLib, right? So because we're including that library, we have access to its jar files, and we're actually saying here that we want to use as a superclass common state for car and also driver. And that gives us access to elements of common state. And it might be helpful at this point to actually see what those are, because it will be a good exercise in kind of understanding how 4DFLib works under the covers. So to do that, I'm actually going to transition. I opened this in Atom here, but it probably makes more sense to now open it in Intellij. So if I go over here in Intellij, I'm going to go to open, and I'm going to go to my courses and projects. So where are my projects, courses, this one, and I want the example, and I want my build file. So I'm going to hit open, and I'm going to open as a project, and I'm going to leave all this as default. If you might want to change your JDK here to be 1.8 if it's not, but if you pick the Gradle file, everything should be derived from that, so I don't think you'll run into any trouble there. And in my case, I already had one, that's fine, so I'm just going to delete it and import again, but if you haven't done it yet, you shouldn't see that. All right, so here is Intellij. Now, Intellij is a more full-featured IDE. I generally do use something like this for my Java work. I find it easier there. But when it comes to like JavaScript and even if I'm doing Node and doing a pretty complex project, I actually find things like Atom to work better. But all that aside, let's come in here and see what we're looking at. So if I open Black Car Service here, I added a shortcut here so I can make this bigger. So here we are in our main, and I also want to look at our models. So let's open car. Make this bigger. I guess you got to click in it first. There we go. So what I'm curious about here is common state. So there is a shortcut here where if you just control click, it's control for Windows or command if you're using a Mac like me. It actually brings you into that class, which is a wonderful thing, right? Because I was just in car and I just command clicked and now it opened common state. This is actually a class from 4DFLib, right? So it's not even something that exists here, right? It's in the jar file that was, brought in when I imported 4DFLib. So let's look at this. So these now are going to be attributes that all classes that extend common state have. So this right here, by the way, is a row ID. We should kind of look at these so you know what they are, because they're going to show up in your databases. For those of you who used Oracle, that term might sound familiar. It's intended to be like this always unique value that represents any row, regardless of what you decide. Now, the reason why we use that is because of the temporal nature of 4DFLib, that you record things through history. Something that has the same ID, like me, so this guy right here, the standard ID, let's say that I'm saving a user record and I have a user table, and in that user table I have an ID of 1, like my actual tuple. Well, if I change, like if you change something about my user record, like you actually put in the wrong birthday, so you edit it later and fix it, now I have a second row. Both rows will have the same ID, but they will have different row IDs. So the row ID is always unique to the row, but the ID is unique to the set of rows that represents that one entity, right? Because every time you get a historical row, you're going to end up with now more than one row that represents an entity. So all of the rows, if I did select star from my user table where ID equals, I think I said 1, and I have those 2 records now because of the historical change, I will get 2 rows back. They will each have a unique row ID, but they will have the same ID, right? This one, the current flag, the CF, will be set as true on the most recent one, the one where you fixed my birthday. If for some reason a row has been marked deleted, it still exists, by the way. There's no black box here for the auditors, but it marks it with this deleted flag. So like if there was a problem with data and you're like, this shouldn't show up in the application anymore, you can delete it. And all it does is actually set this deleted flag. So it doesn't actually delete the data. The data remains, because if you go back in time to before the deleted flag was set, then, it would still show up, but it should because it existed in that point in time, right? So this library is very temporal. It's intended to be like, if I look at the data as it is right now, and you deleted my Brian record, 2 weeks ago, that's fine. I won't show up. If you do a query against, users, I won't show up in there. But if you go back and you look at it was 3 weeks ago and you do a query against all users, I will show up in the records, right? Because 3 weeks before I existed, and that matters. So that's how this works. Now, you don't have to think about this. Like when you delete a record, you don't have to think about this. The library does it for you. But these are those fields that need to exist in each and every table for it to happen. ARSD and ARED are the start date and end date of the record. So when I described that one before where I had the birth date that was incorrect, the original record, the one with the incorrect birth date, would have had a start date of whenever I first created that user record and an end date of when I actually updated it with the new birthday. The second record would have a start date that matched the end record of the first. It would be when I actually edited the birthday, and the end record would be null. The current record is always has a null end date and a current flag set to true. That's how you know you're looking at the current record and not a historical one. This one here is not too important to us. It's kind of one of those facilities. It's there if you want to use it. This is the user ID of the person who edited it. So you can kind of just ignore this or set it to -1, or you wouldn't even see it if you're not using it. But you can optionally keep track of who edits what records, and this would do that. This is the system ID, same thing of what system edited it. This is intended, I didn't dive into systems when I was talking about them earlier just because I didn't want to go like too far off on a tangent. But just to give you an idea, what this is intended for is like in the current world where we have all these different software systems that are accessing a single kind of data store. If you have, say, like a service that wraps that data store and you have Android apps and a web app and, whatever other types of applications that all talk to that same API to talk to your data store, you can assign those things a system ID, and then you know which system the edit came from, like whether it was on the Android app or whether it was on, your regular web app or what, right? So this is a reference to what system made the change. And this is that tenant ID. So I mentioned that all tables created and managed with 4DFLib are multi-client, and hopefully now this makes sense now that you've gone through this yourself. This is the way that happens, right? Again, if you don't use it, they just all get the default tenant ID and you never know the difference, right? You don't have to know anything about this, but it is a very useful tool if in fact you want to. In fact, you can see here that when I run the constructor here, these all get default values, tenant ID being 1. So if it's not altered or changed, you get a tenant ID of 1 there. So coming back here now, this was important because if we look at this, your classes all have to do the following. They have to have their own attributes, which is fine. That's all very straightforward. Notice here that there's no ID, right? You don't have to recreate those fields that are in common state, right? You don't have to have your own ID. You could override it, I guess, but you don't have to because it's already here in common state. So you just create the attributes that are pure to your data, right? Everything else is in common state. And as I mentioned before, we have this reference to a foreign key, the driver ID, and IFDF ignored the actual driver object. That this is that difference again between the object-oriented world, right, and the relational database model. The relational database model utilizes this. the object-oriented world, you don't actually need this, but you want this, right? You want that object in an object. You're like, well, here's the car and there's this driver. And I could do the same. I could put a car's list and drivers or something like that, right? But that is, again, the difference. And if I FDF ignore this, it's not going to try to save this. It's only going to work with this, right? And this is here so that when I do extract a car from the database, I can then extract the driver and populate it here. So that's really it. You also do need this constructor here that calls super so that you initialize these values here. And that's what's happening under the cover. So all your models should look something like this, not in attributes, but you will want this constructor and you'll want this extends common state. What you do here is completely up to you, but those two things you'll want, extends common state and your constructor here. If we look at driver, you'll see the same thing, right? So if I look, whoops, I'm clicking the wrong thing. There we are. So if I extend driver here, extends common state, it has its 3 attributes. It has its public constructor, which again calls super. All right, so that's the model. That's all that was to it. Now the service is the other piece of this puzzle. So let me make this a little bit bigger so you can see it. Actually, you know what? Maybe I'll come back to the service after we run it, just to kind of save, give our brains a break and come back to this. But essentially, what this is now going to be where we put all our logic and actually call the 4DFLib calls when we want to use them. So let's start with the model. Let's do that. I'm going to actually flip back for a moment to the slides here. So we cloned the directory, we changed the directory, we opened everything in the editor of our choice, actually 2 of them. We've been through Atom and now Intellij. And we're going to take a look here at the settings, which we already did. We went through the Black Car service settings, everything was set up for MySQL. We took a look at what we would have to change if we wanted to change it for Postgres, right? And then we took a look at this too, right? Changing the root user name and password. And that's all we need to do, so let's run it. So before we dive into the services, I kind of had saved that for later. Let's go ahead and run this and see it work. So down here, I'm going to do a couple things. One is we had this, right, which was the list of my databases. Notice that right now there's only 24 rows there. In MySQL. And all I did here was use my terminal to log into MySQL. That was in the beginning of the last video. Now here, I'm in my folder for my project, and I'm just going to type Gradle run, and let's see what happens. Now it's going to execute. It's going to pull down any dependencies it needs, and I'm going to come back to this because the screen's going to flip, but what we're looking at here is actually really important. Now this is going to take a few seconds to run because I'm going to show you in a moment why. I actually have some waits in here. I have some, I think they're like 6-second, 5-second waits that are occurring because I want time to pass before I update data. Because as you just saw with that end date and start date, you need to actually have time pass to kind of like really see a difference there. So like if I change a record, I want to say like, well, this record actually looked like this 6 seconds before I changed it to this, right? So in order to do that, as I'll show you in a moment, the code that just ran just had some pauses where it actually just hung and stayed there for 5 or 6 seconds. And this output will make a lot more sense in a moment. This is me editing and changing and re-outputting the data. And we'll take a look at that. But what I really want to show you right now is kind of the output from the beginning. So the first thing is I had this hello 4DF world, right? And if we go back here to Black Car Services, that's this. It's just to kind of show that, hey, we kicked off, we ran our main, everything's good, right? Now the next thing that happens is SLF4J is initialized. That's that logging facade I was telling you about. You don't have to worry about this. This just happens on its own. This is very important though. This is 4DFLib starting up and doing its thing and looking to see if there's a database. See here, it says database did not exist. It has to connect. So this is actually the connection information that happens before that. So it connects, it looks to see if there was a database, in this case, it says, oh, there wasn't a database, so I'm going to create it. So it created the database, and then it created all the tables I needed. So notice here that there's a bunch of tables, only 2 of which are ours, right? So there's driver and car. Those are our 2 tables, but there's also these, and any table that starts with FDF, like the system and tenant, are system tables to deal with that. So remember that I said you can use them, you cannot, you don't have to worry about them, you don't have to think about them again, but they're there. So if you want to incorporate your multi-client into your model using this, you absolutely can do it that way. So that is up to you. They are here if you want or need them. Now you can it created the default system, created the default test system. It actually creates 2 systems in there, one for test, one for default, and then it creates the default tenant. So this is just default data, not something, again, that you have to worry about or be concerned with. This was the database create. Now let's see the output of that. I'm going to flip over here to MySQL, and if I do the same show databases, notice now that I have 25 rows. Notice that the name matches what I said, that we were going to change I think I inserted class demo into the name, where before it was just demo. And if I do a show tables here, you can see that I have those 4 tables that we saw: car, driver, FDF system, and FDF tenant. And just to see what's in those system tables, let's take a look here. So FDF tenant, let's start there. You can see that it's just that main first one that I set up, and this name and this description match what was going on here. So here is the default system name, and it's the system, sorry, I did it again. Here's the default tenant and the default tenant description. Now you can add additional tenants like this, and they would show up here, and this is where that tenant information lives, right? So you can hold on to all that there. The system is the same idea. I'm not going to go through that one. We're not going to really be using it. Let's take a look really quick at what it created. Again, this is not something that for our project here you have to worry about, but remember there was a test system and a regular system, so it created 2 rows for that information as well. Now what I'm really interested in, oops, I'm not in there, I'm not in Bash, I'm in MySQL. What I'm really interested in is our car and our driver. So let's start with driver. So select star from driver. So not only do I have a driver, but look, there's actually drivers here. So remember, I had that function that created the data. So let's look at that, this insert some data. So after it created here the database, and by initializing it with these 2 classes, created those tables for those classes, then I had it insert some data. So that came down here, created the references to the services, which I will get more into in a few moments, but first I just want to show the creation of the data. You can see what we use those services for here. You can see here that I'm just saying save driver, which is a method within this service. So we'll get to that. But the important thing is, remember, you're going to, the object of an object relational mapping software is to make the database interactions as transparent as possible for you, so you can program in an object-oriented manner without having to worry about the differences between the object model and the relational database model. So what I'm doing here is I'm creating an object. It's a driver. I'm giving this driver a name, just like you would in any object-oriented paradigm. And I'm then going to assign the attributes, first name, last name, and phone number, which we saw were the only 3. And then I'm going to save it, right? So if this is an object-oriented, syntax, I don't know what is. The act of doing this created Sam in the database. So when we go here, this record exists because this code ran. Now, obviously, there's more in save driver, and we're going to take a look at that. But again, the idea here is to make this natural, right? And it just became natural. Harry, same thing. And Jack, same thing. And Brian, right? So it created 4 users, and here they are: Brian, Jack, Harry, and Sam. And then I do the same thing for some cars. So I create a car called Mufasa, one called SS, one called pbox, which is the Boxster, one called pilot, van, and CV1, which is actually, I had to throw a taxi in here since this is supposed to be like a black car service and there's no actual black cars, but whatever. It's just a database. So there's these cars, right? And if we search, if we select from our cars table, select from, what was it, just cars, right? Car, sorry, not cars. Select star from cars would be helpful. Car. All right, there we are. So now you can see that I have all of these cars, right? So Mufasa was a Pontiac Trans Am, the P-Box was a Porsche Boxster, the Chevy SS, Pilot, the Town and Country, which is the minivan O'Death, you know, all of these things, right? So notice there's more rows here. I'm going to get to this in a moment. Some records like the Boxster here and the Crown Victoria have multiple rows. We're going to look at that in a moment. That's because of updates and things that happen later. But the initial 4, or no, it was more than 4, but the initial cars are all here, right? That's them. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. 6, that's right, because here's the start of the cars. So those are the 6 cars. Now, once that's done, we wanted to do something with the data, right? So we saved all 6 of those. See, save, etc. Now, down here, we wanted to change stuff. So let's do that. So we, first, we have an example of how you can get a car. So this is an example of a select. I'm effectively here using the library to do a select on cars by name. Now, granted, there is still code in that service we're going to dig down a layer in a moment and take a look at, but what I want you to see is, like, you know, when you extract yourself away from that for a moment, you know, just how fluid this becomes, right? So I'm going to search for a car by name and I'm going to pass in the name I want. And if we go back here and we look at the record, we can see that in fact that is the name here, right? So it's going to return a car by name based on that. And I'm going to put the entire car in this object, right? So now I have the car as an object and I'm going to print that out. So let's take a look at that in the logs. So when that ran, we ran this. It said driver driver ID should be empty. And here we are right here, car, the model. So car, Boxster S, driver ID should be empty, -1. So driver ID should be empty. This was a -1 because there was no current driver. And if we go back and look, we can see that. Look here, so the Chevy SS, not the car that we're talking about. Does this one have a driver? Nope, that one doesn't have a driver either. This one does, so Mufasa does, right? So if you look, Mufasa.currentDriverID equals Brian.id, right? But if I come down here to the Boxster, there's no current driver, right? So we needed to add that. So right now, we haven't done it. This is just now put to prove that there was nothing there, and there's not. Now I'm going to assign somebody to drive. So I have P-Box here from where I got it by name, and I'm going to assign its attribute current driver ID to the ID attribute of the Brian object. I'm purposely going to wait 3 seconds because I wanted some time to elapse, and then I'm going to save the car again. Now notice that I didn't have to specify that this was a, you know, the same car or whatever. I just passed the car. I didn't have to, like, the ID was obviously in there because it's part of common state, which is part of the car object, but you didn't have to think about it, right? You just had that object, you changed an attribute, and you're like, okay, resave this thing. Now, let's see what that looks like here. So if I actually go to the database, and let's just select star from car where ID equals, I don't remember what the ID was for, oh cool, got it. All right, so now I've narrowed it down to just the Porsche Boxster. And if we look at, we haven't done all of these yet, by the way, there's more coming, but if we look at the start times, notice that they're all obviously on the same day, but at 13:14, 31 to 13, 14, 34, this was the current record. Notice that the driver ID is null, and this existed for 3 seconds, right? Now I've saved this 3 seconds later, and we got this guy. Driver ID is no longer null. It is 4, right? Notice that neither of these have a current flag set to true because as you'll see as we get further down this, we're not done yet. We're going to edit this again. But at this point in time that I had saved this, this would have had a current flag of 1. These records wouldn't have existed yet, and it would not have had an end date. This end date would have been null, just like this one is. So for a while now, all of I think 6 seconds, this record was the current one. So let's take a look at what happens next. So now I'm going to, this by the way I didn't have to do, I just did because I want to be explicit that I'm getting the information back from the database so that you can see that the changes happened there. But once I had the object, I could have just kept saving it. I didn't need to keep getting it. That would have been fine. But either way, so I have this and I get it again, and then I output the new thing. And notice here it has the assigned. So let's look at our output, and you can see that here we are. Brian's Boxster S driver ID 4 assigned, right? So that's how this works. Now, we do more. Now next we say, let's get all of the cars with the year 2001. Now, if we look at the data, we can see that obviously the Boxster has it, but it's not the only car. So the Boxster has it, and the one cab in here, the Ford LTD Crown Victoria, is also a 2001. So notice here this is a list because multiple cars can have the year 2001. So we're expecting to get back more than one car. So I'm expecting to get back a list of cars, and by asking for them by year, and I passed the year. Now, this is just a standard object for loop where I'm going to iterate through my cars, and I'm going to pull each one out, right? And as I do, I'm looking to see that there should be a driver, and to get the driver ID if there is. So this now is actually populating that actual driver object. So if you remember, if we go here, remember this guy here? Now you could have done this in the service too. I'm not going to go off the deep end here, but this thing was probably null at the point that we were at. The service, we'll look at it later, but the service probably wasn't populating this when you were actually getting the cars. So what we're doing now is doing that, right? We have this, we have the driver ID, but we didn't have this object actually populated. So if we go back here, we can see that if the driver ID is greater than or equal to 0, meaning there is a driver, it's not a -1, then we're going to set the current driver using the driver service, get driver by ID, and we're going to pass it that current driver ID that we have. So this is going to be a way to actually go to the database in the drivers table here and pull out these drivers by ID, populate them into objects, and then save them here so that we have that driver to use. Once we do that, then we basically just say, okay, put the driver in, or put that there's no driver in for the name for this driver string, and we do an output. So let's see what that looks like. So for every 2001 car, we should output their drivers, or note that there's not a driver if that's the case. So we go back here, and we left off here, and we see that for 2001 car, Brian's project, which is the Porsche Boxster S, is driven by Brian, has a current repair status of false. And the Medallion 1, which is a Ford LTD Crown Victoria, which is driven by Jack, has a current repair status of false, right? So that's this. You're looking at the output of this string right here. All right, so now we wait 6 more seconds, and then we change all the 2014 cars sorry, that's out of date. This should be change the 2001 cars to a status of needing repair. So we again are going through that same cars array that we had up there, But this time, as we go through it, we're going to set the in need of repair attribute to true for these cars. And then as we go through, we save them. And if we look at our data now, we can see that happen. Let's go back down here. So I don't have the Crown Victoria up here, but we can look at that here, but I do the Boxster. And you can see here that this next record here has a in need of repair set to 1. So this is where I did that, right? I set the is in need of repair. This happened, let's see, the last one ended at 13:14:40. This one starts at 13:14:40. The last one did end for, it was 6 seconds. It was from 34 seconds to 40 seconds. This one existed for another 6 seconds, which we'll see in a moment. And if we look at our Crown Victoria up here, we should see the same thing. Is this the right record? Is in need of repair 1. Yep, so I set them both to is in need of repair. So this one and that one got set. And then we waited 6 more seconds. And then I just set, I didn't output anything here, notice. And then after another 6 seconds, I wanted to get just one of those cars. So I got a new version of that, which is to get those cars. But instead of iterating through it, I just arbitrarily got whoever was the first in the list, which I think turns out to be the Boxster. So I just said, all right, instead of changing both of them to false, I just changed the first one to false. And then I saved it again. And you can see that here, this last record has a current driver still of 4, but is in need of repair has been set back to 0. And notice here that there is a null end date. The start date for this is the end date of the previous one at 46 seconds. And everything else is the same. All that changed was that. But you can now see, if you look at this data, you can see the historical progression of this vehicle, right? And you can see that if you did a query for, what was everything in this database, what did it look like at 13:14:36, right? I would get this row, right? And if you did that for everything in the database, you would get the rows that applied for that in the entire database, right? So that's how it's temporal, that's how it works. You don't have to, these attributes over here, they're all managed for you. That's all the common state stuff. All you have to think about is this, right? This is your stuff. This is not your stuff, this is your stuff. And you don't have to honestly think about this much. Once you know how to use the library, all that is done for you. But like any library, and this is part of the skills that we're learning here, it takes time to get to know it and get to know how it works and to reap its benefits, right? That's just part and parcel of the project and the process. So let's finish this out here. So we set just the Boxster back to false, meaning that the one cab in our arsenal is still in need of repair, but the Boxster is fine now. So we saved it, and then we printed this out. So let's just go back and correlate that we're in the right spot. So here it is. And then we said, okay, so let's get all cars, this time with history. So we hadn't done this up until now. I was just getting the car at the current point in time. But since this library allows us to be temporal in nature and get all of the history, this is an example of how we might do that. So I'm using a service called get car by year with history, same as get cars by year, but notice that I added the with history. And then what's going to happen here is I'm going to get this complex looking thing back. Now, what this is a list basically of a different type of object. So what we have here is an FDF entity of type car. Now, what this means is an FDF entity, let's take a look at that. I'm going to do the cool command click, and then we're going to make this a little bit bigger. The FDF entity is, and we're going to talk more about this when we get to the temporal piece, so you don't have to worry too deeply on this now. And I'm not really asking you guys to, kind of do much in the temporal piece or the time piece. I just want to explain what this is so it makes sense. But what this means is that you're going to have here an object. Anywhere you see S, so this is reflection, by the way, basically what we're saying is that the object you give me, so in this case, I'm using car, right? Whatever is here needs to extend common state. And remember that car does extend common state, right? And because we do that, we can make certain assumptions, like getting something by RID or things like that. But we'll get back to that later. But what we have in this object is something called current, which is of type S. So in this case, we created it with car. So this is a car. And then we have a list of type car, that's history. So all of the records that are, don't have the current flag of true, they're going to end up in here in this list. And the one that does have the current flag of true, that's going to end up here in this current. And this is just the entity's ID. So like if it was car ID 4, this would be a 4 here. It just makes it easy to get to that quickly. But it's also embedded in these as .id. So that's all this is. It's actually just this object that we use to encapsulate both the current record, which is just the record.current, and the historical records, which is a list then of all of the history that comes with this record. 4DFLib now manages, when you ask to query that thing from the database, it manages getting those records and putting them in the right place and handing you this back. So you can say, oh, okay, I just need the current or I need the history. Now, if you don't care about the history for this particular function, you don't have to do this, right? And we saw that here when we went back and we asked for just get cars by year. Notice that I just get a list of cars. There's no FDF entity because I didn't ask for history, right? So you don't have to do that. And we'll look at the services so you can see this banged out later, but that's basically the idea. So this, now we have a list of these. This has a current and it has historical records for the car. Now we iterate through that just like we did before, except now the things we're iterating through are this, not just cars. And you can see me use it here. So first output the car's current status. So I say 2001 car after updates, and then I say car with history, which remember is our current object of this, dot current name. So I'm getting the current record's name. So if we go back here, we can see that 2001 cars after updates, Brian's project, which is the name, which is a Porsche Boxster S, has current repair status of false, right? Because remember, we changed that one back, so that worked well. And then it says, okay, now show me the history of this car. So I have this output here, which for my part is here. And then there's 3 historical records for my Porsche Boxster. So I do a quick iterative for loop through that history, right? So here's my cars with history, dot history. That's that list that we saw here in 4DFLib, right? So that's this. And what I do here now is just iterate through it, and I pull out each car object out of it. And as I do, I print what the record was at that time. So you can see who drove it and was it in need of repair. And if we look at the times, you can see the whole thing happen, right? So the first historical record, there was no driver. The second historical record, there was a driver. The third historical record, there was a driver and it was in need of repair. And the current is here. The current says it has a driver, it's no longer in need of repair. And you can see that all of that has happened. So that is that one. The second one here for the medallion, the actual cab, is much simpler. I didn't assign a driver, and all I ever did was flip it from, not being in need of repair to being in need of repair, and then I never flipped it back. So if we look at the history on that one, we can see that the repair status was false. And then when we did flip both of them to true at the same time, this now reflects that it was in need of repair, but that one never got flipped back. So there's just one current record and one history record. And that is pretty much the end there. So there also is a custom query that I included. I'm going to dive deeper into this in the service area. So I'll show you that when we get there. This is just basically to show that you can create services like this that allow you to ask for specific things. And it will make more sense when I open the services in the next one.